Okay, we should be live now. Okay, so we have David's testing part 2 currently pulled up. And what we were trying to do is log the actual day, the day number in which the lion decided it was time to eat a little bit more. So we have our array of meals per day listed out right here. We've set up a variable for our Too Hungry day. And so the goal was to cycle through each one and collect the averages as we move along, and then to showcase which day the average finally got below 4. So what approach did you take with this?
At first I was going to use some sort of loop and go through the indexes. What did I try to do first? For each, I tried to use like a for each loop, and then I said, well, since I want to maintain an average, I want to use the accumulator because it just sort of stores that average. I was trying to avoid if loop or for loops of any site, any type. Use the built-in looping functions. So I decided just to use a reduced loop and then put my conditions in for if the average is 4 or below, and if I've triggered the Too Hungry day yet. So you enter the reduced loop, and let's see.
So you're first checking to see if the average is greater than 4 first.
Right. So greater than or equal to 4, 4 above, and then if it is greater than 4, we return. Well, first I console log the average and the day in that day, and then I return the accumulator, which is 0 at the beginning plus current, and current is the value of the first index for the first time through. So I start keeping the total number of meals in the accumulator, and each time through I do an average on it. So the very first day the average is actually well, I guess the first time to loop the average is undefined, but
oh, okay.
0. But until at the end of the first time to the loop, then we have the average for the first day. Then each time through the loop, I just update the average and test it with the statement, the if, the if else. And the day we hit the Too Hungry day, the day that the average falls below 4, I needed to do a test to make sure that we already hadn't passed the Too Hungry day. So say it was the last day, we know someday previous we've already hit a Too Hungry day. We don't want to write over Too Hungry day, because Too Hungry days holds that information of what index it was for that day. So that's why the not too hungry there is in the not too hungry days. The
Not too hungry, yeah.
So that we only set that Too Hungry day once. No, I do feel like this is an anonymous function for reduce. I do feel like it should be its own function and then called with the reduce, just because it's a bit complex, and if we have to do debugging.
Yeah.
But
What do you remember what number you got back for
7.
7? Nice.
It did pass the test, so.
And it passed the test. It's good. We got a number back. Yeah, let's look at the test that you wrote here. So this second test is expecting that Too Hungry day falls within that acceptable answer range based on the number of days that we have logged in that array.
Right. So on line 95, the second expect. All it's doing is to see that exactly what Rick said, that the day is between 0 and the length of the array. And then I give my fail message and pass message. The first expect was the one that was already there, just to make sure the Too Hungry day is a number.
Right.
Gonna run it, or?
I didn't realize you could put like 0 is less than or equal to 200 days, which is also less than. Like I put an and.
Yeah.
That.
What might happen here, based on our little talk earlier with implicit coercion, and so 0 is less than or equal to 2 hungry day. That could be true. Let's assume that that will always be true in this case. And then true is less than
Oh, okay.
meals per day dot length, which will also be true.
So this is there's a bug in the statement.
So this will pass, but it may be difficult to actually get it to actually fail. To fail in this case.
I guess I'm used to that constructor from other languages,
Mm-hmm.
where that actually works.
Yeah, JavaScript has a weird type system.
Yeah.
Yeah, a little bit different. Does its own thing.
Okay.
But no, it's good. Anyone have a link to their solution that I can
Yeah, I can.
pull up?
That
And
is-
honest, go ahead. I think it took me way longer than it should have. It took me almost 2 hours. I mean, there was some stuff going on at home.
I just like.
to write that reduce call, and I don't know. It just seems like it took too long to write.
That is
Fine.
a good example of why whenever I write tests, I try to make them fail. I modify my input so the test fails, so I know that it is not, succeeding every time.
Right.
I think after 2 hours, he was probably like, yeah, that's good.
That's-
I'm not gonna test the test.
Yeah.
All right, I love seeing we have 2 solutions and so far 2 reduce calls. That's great. So what was the approach for here?
Well, first I figured that we had each day was how many meals we had. So I wanted an array of the cumulative total, or like as we went on, how many meals had been had altogether. So I did that with reduce, taking adding the previous to the current. Yeah, so that returns an array of the cumulative meals. And then I took that and formed the average using the index as the day number plus 1, because index starts at 0. And we're not starting days from 0. And then the find index, I wanted to find the first time it was under less than 4 and return the index, which is the day, so it's plus 1. And that sets the value to 200 a day, which was 7, the same as.
So far so good. Yeah, this is nice.
In terms of, makes a lot of sense.
I kept being like, surely I can just do all
Well,
this
it
and
just-
reduce.
This was a little bit complex because we had to calculate an average while we were
Yeah.
going, so it kind of threw in a different variable into the mix. And then here's our expect. Expect that it's going to be less than the actual day, and that day is less than or equal to meals per day dot length plus 1 should be within the number here. Okay, so what was your approach here?
Well, the plus 1 is because it was just the logic of the days. So if we start on day 1, then index 0 is day 1.
Mhm.
So the last day is dot length plus 1. So it's got to be bigger than 0 and less than the final day.
Less than the final day, right? Because if we have an array of, well, let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the length of the array is 10.
Yeah.
So we have 10 days that we can select from.
So length is.
Well, wouldn't it be 11 days? Because they want 0.
Now, if you're starting with a 0 accumulator, then you might
10. Because yeah, 10 is like that.
if you're assuming that the first day is a 1, then yeah, that should be good. But with those zero-based indexes, we do have to be careful with bounds issues. So yeah, cumulative total.
Yeah, that is a super common class of errors called off by 1 errors, where you forget
Yeah.
to subtract or add 1
Based
all
on
over the place.
Yeah.
Yeah.
Yep, off by 1. That's all it takes.
It's a little confusing because you have the index, you have the day that he eats them is not the index that he eats them.
Yeah.
Yeah, exactly.
You run into that all the time.
Because in real life, not everything begins at 0. Especially parking garages, as we're well aware. Those levels. I think I've only seen 0 and negative parking levels in Europe, if anywhere. But
With actual minus signs?
with actual negative numbers, right?
No kidding.
Right.
Wow.
Yeah.
Makes sense.
I would love. To me, I would love that, but yeah.
I've never seen it just always B or L, L.
Or
Mhm.
Like underground.
Anyone else want to post links for theirs?
I don't know what mine looks like right now. I didn't work on it after Friday.
Okay. Nice.
So there's that's definitely a bug in my code, because when I run it, I only run day 1 through 9. It doesn't hit that 10th day. But yet, I don't get an error. I don't get like a divide by 0 error with my average on the first day that I reduced loop.
Is it just because it's printing off?
Well, like in the very first time through the loop, it prints the index, and it comes out as 1.
It's printing out the indexes of 1. Okay. So it might be it might be skipping the first one, the 0.
Well, why?
Yeah. It's interesting.
If you run it, look at the output, it does day 1 through 9.
Let's see. So it's in
Yeah,
this part.
So the first console log says day 1 average number of meals 5.
Right.
But why isn't the index? Why don't I get a divide by 0? Or why don't I get?
Day 1.
Why is the index 0?
index.
On day 1.
Well, and what's also strange is you're logging. If it's logging day 1, there's not actually a explicit IDX plus 1 anywhere here, so
Yeah.
this should be dividing by. Yeah, that should be dividing by 0 at some point, at least at the very beginning.
And it stops at day 9. Doesn't give me day 10.
I wonder if there's something going on with reduce where it. No, it should still do it. You should get a 0. That's interesting. We should take
Yeah.
we should take a look at that. We should take a look at that some more later on. Yeah.
Does it stop at day 9 or index?
Yeah,
Day
what's-
9. Which should be index.
What's interesting is that you're logging on 67. You're logging day plus index, and you said the very first log that you get is day 1,
Mhm.
which
Right, yeah.
tells me that it's bypassing the first index altogether. But you're also getting the average number of meals as 5,
Right. Which is correct.
so it's not passing the first index, but it's starting the index at 1 somehow.
Day 2, the average number of meals is 4.5.
Yeah. So somewhere in here, this IDX.
What happens when you divide by 0 in JavaScript? Doesn't
Yeah. We need to write
is it
this.
undefined or not a number?
It should be not a number.
It's infinity, actually.
Oh.
I got infinity.
Infinity, there we go.
The first time I wrote this.
To infinity and beyond.
At some point when I wrote this,
You don't see
it
that
did
that
show
often.
average infinity when I was printing out just the average.
Average
And then infinity is a truthy value.
It's also greater than 4.
It's a good one now.
It's also greater than 4.
Greater than 4, yeah. There you go. What about this?
Oh, that's right.
Okay. So at least we do have a finite number somewhere in there. Yeah, that's really interesting.
Yeah.
Any other thoughts? Didn't mean for that to take a Twilight Zone turn. Okay. It's not magic. I refuse. Okay, let's take a look at this Soda, Socrata's Open Data API. So what I've done is I've just gone to soda.demo.socrata.com, and they have some example sets. So this is a Socrata earthquakes example set here. Now when you actually go to one of these pages, again that's soda.demo.socrata.com, when you arrive at one of these pages, you're going to see their own little table that's been formatted. You can organize these based on your fields. You should be able to. I should refresh that. Oh, well, in the case of where I currently am at, there is internet.
Wow, okay.
Yeah, this is a Chrome thing. So whenever you don't have internet, you can actually say everything's going to be okay or not.
On the first one.
It was working this morning, I promise. What do we have there? There we go. There we go.
Oh, I figured it out. So the way reduce works, it uses like pairs of numbers in your array. So on the first column of reduce, it'll actually return the first and second indexes of your array.
It'll put them together.
Well,
Or-
it returns like 0 as the previous. It returns the first element of your array as previous, and the second element of your array as current.
Okay.
And since they're operating on that second element, which is index 1, it returns, so the first time you call reduce, the first loop around the index will always be 1.
Okay, so we've gotten too accustomed to setting that accumulator first.
Yeah.
Yeah, but in the case where we're actually dealing with numbers,
Yeah.
it'll basically take the 0, and then
Yeah, in the first call. Yeah.
for both of them.
Yeah.
But
It's
the
buried in-
accumulator, the first time through, my accumulator is 5.
Yeah, see that's the strange
Really?
thing about that is we're not getting 4.5, we're getting 5 on the first go around.
I don't know. I'm just reading the Mozilla documents and that.
Let's put it through the Python tutor
No, there you go.
later on. All right, so on this back on the Soda page here, we have their table, which we can actually arrange by these different values. So we have our fields, or we have our columns up here. We have our data set. Now, if we go to export, we have the ability to actually download the data collection in a variety of formats. But we also have the ability, and they don't make it very easy to find, we have the ability to access the API right here as the first option underneath this export tab. So if we click on this, it will expand, it will drop down. It says the Socrata Open Data API provides programmatic access to this data set, including the ability to filter, query, aggregate data. For more information, view the API docs for this data set or visit our developer portal. So we're gonna actually scroll down to the API endpoint. And what's really neat here is they actually give you a list of valid field names that you can choose from. So if we select this and copy it, I'm going to go to the new tab, and I'm going to paste that in. We get back a lot of JSON, and if you have the JSON view extension for Chrome, then it will return this data collection back for you. So this is one approach that you can do to test what type of data you're actually going to be getting back from your requests. Another benefit of Soda is the ability to use SOQL or some structured queries. So if we look at this URL, we see that we're requesting a JSON file, but then here's the beginning of our query parameter with the question mark. And what does this look like? Just like SQL, right? They have a $, but then they have a where clause statement right here. And they're checking just a field. They're checking the magnitude field, which is right here. They're checking. They're actually requesting only the set of data where the magnitude is greater than 3.0. And if we were to actually copy that and paste it in here, this is what this would look like. So when you actually hit return in your address bar, the spaces will get formatted to these percentages or mods. So mod 20 is essentially the same as a space, and that's what the browser will do because it can't have a space. It's either going to try to add a plus sign or throw a character where it actually does recognize what that value should be. So you can still see the $ where equals magnitude, and then here's our greater than, and then 3.0. So notice the first record has a magnitude of 3.1. So I'm going to remove the 3.0, or at least just the 0. Since we're only selecting things that are greater than the value we enter, we see the first record has a magnitude of 3.1. Therefore, if I change our query to 3.1 in the address bar, we should see that this first record should now disappear and get replaced by a larger value record. And we do, because now the magnitude for this one has 3.3. So this is really a really good approach of being able to filter down your data set from this point versus getting all of your data into your application and then filtering it down. Any questions on this part? It's really neat being able to use SQL-like syntax to get the data collection that you want. You can even update this based on user input. So your application can request a different endpoint based on what the user's doing. So each time it could be a unique request. Or if you wanted to prevent additional AJAX requests, you could get your base collection, and then your filters could then change what's being displayed based on that base collection. So there's a couple different approaches that you can take here. But it's definitely important when dealing with a very large set that you filter this down accordingly, because there can be thousands and thousands of records. You want to do another one? What should we filter by next? Number of stations, depth? Let's see what depth does. What should depth be greater than?
74. Just to see what comes up.
And notice how much we still have. Because look at our scroll bar on the right.
Yeah, some of these data sets are very, very large.
Look, I've changed it to 200. We're still getting a lot back, because most of the time these data sets or collections, they actually go back in time.
Yeah, that's what I was wondering. How far back does this go?
So this is probably one of the most important considerations to make, is to see how far back your data collection goes, and you can filter it based on something that's a little bit more current. Yeah, so we have 2012 for this particular record here. And you'll also find that sometimes these data collections are dated, so you're not actually getting the most recent information. So that's another thing to check for as well.
You filter by date and just grab what's on the top.
Probably newest sort.
Mm-hmm. Yeah, you can actually do windows where you can say date is between. And the documentation for that is actually pretty helpful. So this is back on the dev.socrata.com, and I'll actually go ahead and Slack this out. Provides some really useful tips for these queries. So this is good because you can see like the where. You can click on where, and it'll actually take you to some examples of how to use where, where you can attach different operators. So here's an example of where we use where and include an AND operator. And these are the list of other operators that you can also combine with where.
So, is the query? Sorry. So I pulled up a database. I took that URL. I stuck it in another tab. I got a big JSON. I tried to use where. It says unrecognized argument where.
Do you have a $?
$sign.
You have the $?
Question mark $sign where not equal.
$. Yeah, question mark $, where equals.
Not equal. But you did complain about the not. Oh, you did complain about the not. How would I use not equal?
You'll probably want, let's actually see. There is a not operator.
Oh, just
Yeah.
where not.
Yeah, you could have a not with that, for that being equal to that.
So use not somewhere.
You could have a basic range and then kind of adjust it down. So this will be a really good friend. Again, the collections and sets are usually really well. Socrata has really nice data sets that you can actually look through and find. And they have lots of helpful resources off to the left-hand side too. So, and again, most of the sets are going to be coming back in the format of JSON. So it should be really easy to work with. Any additional ideas for projects? I'm just curious to see what people are thinking, since we'll probably form into teams as early as Wednesday this week, actually.
Yeah, I want to look at Seattle building permit records. Just like maybe do some trending on how many building permits are in work and how long they're taking to get, from issued.
Mm-hmm. Be able to pick up on the status of a particular permit. And,
Well, not maybe just a particular one, but a trend on, single-family homes, how long they're taking to get issued for new construction, and also like how many single-family home are being converted to multifamily homes. So like there's a whole lot of lot splitting going on.
Right.
And just to see like what they're doing to increase housing in Seattle and whatnot.
that could be really good.
And then there's also, Seattle has recently implemented, you can no longer get a demolition permit until you're issued a building permit, because they don't want to reduce occupancy in the city. So if you have a property and you want to demo your house, you can't do it to get your building permit, but now that costs you money because you have to wait to get your demo permit to demo. And whereas before you could get your building permit and you could start building because you've already demoed, but now, so how much is that costing? How much is that costing property owners, and maybe start a class action suit against the city?
It's not cheap.
Yeah.
I'd be interested to know.
Right, because if it costs you a month of whatever that property's worth times by everybody in the city trying to build something, that's a lot of money the city's costing them.
Be interesting to know if there's a way that they're tracking how much of that data is being used or how many people are accessing it.
Right, and it's like, yeah, the data's there, and why it's like, well, they know that better than anybody else. It's like, yeah, they have the data, but has anybody looked at the data? Right? It's like, you see a lot of buildings out there that are just sitting there. They're all like closed off because like they can't be demoed. Now they're just lights, whereas they could be just demoed and flat.
No, I think that
Food
would
for
be.
thought.
I think that could be a really good use case. Yeah. Any other ideas floating around? It's kind of challenging, isn't it? Especially when you only have a week. I kind of like to think Project Week more as a prototype of sorts, and not really a project, because again, there's not that much time, and it's easy to really kind of get your scope way out here. To be able to determine like what it is that you want to accomplish. It's much harder to define a narrower scope, but it will save you a lot of headaches. One of the biggest challenges for a team is to have stretch goals, but not to build their projects expecting those stretch goals to even be completed. So they'll actually start, even though they've started their scope out here, they're still building for out here because they're expecting to hit those stretch goals. So the biggest tip that I recommend everyone just being aware of is not to stretch yourself so far when actually putting together these user stories for your projects. Keep it pretty basic. Just getting the data, rendering that to the page, and we'll talk again about some of the requirements for that later on. Okay.
Can you go back to your search query one more time? When you were manually editing the search bar.
Let's go to here. Do you know which one are you on the earthquake one?
No, I'm on the permit one. So,
Yeah, anytime that you have like a space, you'll need to have a %20.
even if it's within a string. So at least the JSON, like it says permit type. No, there's no space in that one. So I don't include the quotes. It's all wrapped in quotes.
Yeah, this would be just in terms of your query. So your query is expecting spaces. So in between your operators, you would want those %20.
Okay. Yeah, so there's no equal sign
Now, if I wanted to say equals, I could change this greater than. And I'm not actually getting anything back.
Wow.
Because this is a very specific request for a depth.
Oh, I see.
Now, if I wanted to change it, I see that depth is actually equal to 387 on 1. And this is more manageable.
Yeah.
So pretty cool. Try exploring the data sets, see what information is useful, or what just anything that interests you, honestly, and then get the JSON file from the export tab, and put it in your browser and just start experimenting to see what different queries you have available. And again, that export is located right here. And then you can get to the API right here. Okay. Before we go into routing and controllers, we're approaching the top of the hour already, so we'll take a 5-minute break, and then at 10 o'clock we'll set up the routing and controllers. We'll do a basic page demo in between there. And we'll also do a basic Node and package.json demo as well, especially for assignment prep. It'll be good to talk about. So, 5-minute break, and we'll come back.
You get it up quick.
Maybe I'll hang with that slide deck right there.
Did you give us these slides?
What's up?
Are these slides on the repo?
Are they already there?
Sorry?
I'll have them up if they're not.
Yeah, I don't think they are on lecture.
Okay. Yeah, I'll have them up later on then. So sorry for no spoilers today. Okay, but welcome to week 3, where we're going to be covering controllers, the last part of our model view controller layer. So we're going to finalize this SPA, or single page application structure, that we've been kind of discussing throughout the course of this course, and we're going to implement today some routing and controllers to be able to influence what happens. So if you remember when we were discussing some of the jQuery lifecycle transitions. So when jQuery first started off, it was kind of the tool for the job. It was like the one tool for everything. And then other libraries like Handlebars came along and abstracted out some of those pieces. Today we're going to do the same with Page.js. So our handle main nav section is going to be essentially extracted away, and Page is going to be able to handle that for us. Tomorrow we're going to be discussing REST and APIs, and so we'll be utilizing GitHub to be able to actually fetch our repositories from GitHub and be able to implement those into our portfolios, which is really neat. It's probably one of my favorite days in week 3. And then we're going to discuss deploying. We're going to take it on a high level and be able to deploy the full web application. So beyond GitHub pages, we're actually moving into the realm of deploying with actual servers. So we'll be deploying not only our blog app, but we'll also be deploying our portfolio assignments as well. So this is what our days will look like. Routing and controllers today, REST and APIs tomorrow, deployments on Wednesday. We're going to go a little bit more in depth with Page.js on Thursday when we talk about managing state, and then our project kickoff will commence on Friday. So not too much left. We're almost there. Yep, got that done. Here's some examples, by the way, of some other approaches that previous students have taken with the testing. I just wanted to kind of showcase a few of those. So we have a find index method as well here. It's just a map that gets the average down. Returning the average there. Here's one with just the traditional for loop. Yep.
Oh, well, I have a question about, so he used the map and then he used find index. That's 2 times through the array, right? I mean, whereas like reduce is just once through.
Mm-hmm. Yeah, this approach, they're going through meals per day, and then they are going through average meals per day. So there's actually 2 different
And does a map
2 different collections.
return another array? So you're actually creating another, you need another variable to hold it?
If you wanted to have reference to it, you would, yeah. Yeah. Otherwise it's gone. Here's one with the traditional for loop. Here's a for each. Couple for eaches. So again, just showcasing all the different possibilities. Here's one with a for loop, a traditional for loop. But notice we're actually creating new dates, which is essentially starting a timer. It's essentially seeing how long it's actually taking to calculate, to go through all the days and process everything. So it's almost like running a little performance test, which I thought was pretty neat. And this is pretty similar to what we've seen before for actually writing the tests. And again, that's also pretty similar.
So definitely want to use the and.
Mm-hmm. Yeah, if you have a couple different operators, you want to use the and for those. Okay, so our objectives for today, we're going to be experimenting and utilizing client-side routing to see how that interacts with the browser's history. So we're gonna jump into the actual history object that that page is actually tapping into. And then we will build out a controller layer to complete the MVC architecture. And I want you also to just keep thinking about project ideas and what you might like to see kind of take shape towards the end of this month. So a controller, if we're thinking about it, essentially has 2 main parts. We have the server that maps the request to what we call handlers. So with jQuery, we had basically just click handlers. But for Page, it's going to be actual routing handlers, like what's actually being registered in the URL. And then the route will map to a controller for us, which will dictate then the logic or the functionality that we want to begin or kick off once that route is actually passed. So the route maps a URL to a controller, and then that handles the action of the function. Those are the 2 main pieces here. So we can imitate the behavior of updating our address bar without going through all of the typical workload to do so, which is really neat for Page to help us out with. So sometimes it's referred to as spoofing or tricking the browser. So when utilizing an actual router, no literal file is needed for every URL request. So in this example here, we see blog.html. We could also, with routing, call this /blog, and they're essentially going to be the same page, whether or not there is an actual blog.html file present. So in the case of our about, there won't be an actual about page. We have an about section, but we can make the user think that there is an about page, and it'll load immediately. The request will not fire because it's already been loaded for us. So this is improving the user experience. So I want to talk about the history, because that is a literal object which is on the window. All right, so I meant it when I said no whiteboard. These will now be hopefully clearly visible on the videos. All right, so we're talking about the history object. Therefore, we have access to it on the window object, right? Now with this actual history object, we get some other properties. If you had to guess, what do you think history.length is actually representing?
How many we have in like our stack.
That's right. It's the number of pages that we can say have been cached in the browser. Now what about this one? History.back. And let me throw that on
Is
there.
that a handler or,
What's that?
is that a handler or an event? Or just what does that do?
So we see a property that's on an object that's equal to a function.
So that would probably take us back one.
Yep. We say it's a method to traverse back one page. We also have history.forward. Assuming there's a page to jump ahead to. But what if we wanted some greater control? We can use history.go, which accepts parameter of n, which is again just a method to traverse n pages. So if we were to say history.go and put a 1, we would advance 1, which would be the same as if we did history.forward. If we did a -1, it'd be the same as if we used history.back. But we could also do -2 or +2 to go back 2 pages or ahead 2 pages. So here, for example, if we actually go into the console, here's window.history. So there's our object, which has a length of 5. And we can just call history.back. We move back a page. We can call history.forward. Go forward a page. Notice the address bar is updating when we're doing this. We can do history.go -3. Whoop, if we spell history right. So now we're back at the actual main soda.demo.socrata.com site. So another piece of information that is good to talk about with the history object is the history.pushState method. And that accepts a state object, a title, and a URL. So this is where we can literally push another, essentially another state to our window. So if we go back in here, let me advance all the way forward. So we're all the way forward in our browser's history. There's nothing left. I'm gonna first, if we look at this method, it accepts a state object. So if I create that state object right now, I'll just create an authentication object with a property of user, set equal to my name. So I've set up that object, and now I can history.pushState. By the way, I don't have to include, I don't have to actually have an object if I don't want to. If you don't include one, it'll be passed as null.
What do you mean by the state object?
Yeah, if we look at this right now, so let's actually go back to history.
Oh, it's not okay, the property.
So it's this is just another property on history. History.state, which is currently null. There hasn't been anything actually signed for this particular route. Then when we call pushState, when we invoke pushState, we actually have the option to pass in a state object. So I can say my authentication object, which is the user Rick. The title is something that actually isn't really used in browsers. So we can just call that next page since it's going to be the advanced page. And now this last part is what is actually going to be updated as the endpoint to the URL. So I can call that welcome. And this is our method here. So watch what happens when we hit return, what the address bar shows. So now we've appended this welcome to the end of our address, and we haven't even updated. We haven't had to make a new web request response cycle. The page did not refresh. We just literally added added a new history object to our state. So now if we look at history, the length has been updated to 6. And now that we see that state is no longer null, there's actually an object in here. Now what happens if we go back?
Sorry, I'm just, what does that do though, the object? What is that?
It's being placed on history for us to have access to if we need to later on. So when we actually get into managing state on Thursday, we're gonna, it's a good question, we're gonna be able to, yeah, it's not like, and here's this. We'll be able to actually pass this information along in our application, which is really good benefits. So now if we go back and look at history.state, we see that the state object has been updated to what its previous state was, which was null. And we can go back. We can go forward. I was about to say back. We can go back to that page, which is actually forward, and we see the address is updated, and we have our state object present again.
Now, when you refresh, if you go back after you refresh, will that still be there?
Yep. And in this case, we're gonna get a 404 because
Yeah.
there is no such thing as that. So, yeah, good point. We've essentially added it to the history, so it will persist if we refresh, which is good news for the address bar, and in this case for the site we're on. Not so good news since we put in an invalid endpoint. Okay. So our apps routes are essentially the only way that the world can interact with the resources we have. If we have a valid route, we can showcase exactly what we intended to do. If we request an invalid route, as we just did, we don't have access to it because it doesn't exist. So therefore, it's not a resource. So speaking of resources, here are the verbs. In particular, the get request or the get verb. And notice the different endpoints that we're actually accessing. So we could say that we're getting a general resource here for the about section. But as we move along, we can see that the specificity of the resource that we're actually trying to obtain can change. So we can say we want to get only the article with like an ID of 42. Here we want to be able to go to the page where we can edit that article with an ID of 42. And then if we wanted to actually make a change to a particular article, in this case an article with that same ID of 42. And these are built out based on your app specification. So these are not necessarily standard routes right here, but these are routes that are generated or actually built out by the developer. So we could have made this essentially any endpoint that we wanted to. But the important piece is that the endpoints actually match what our functionality is expecting. So if we have an endpoint that's not being expected by the function, we can't do anything with that endpoint. And we'll showcase what page will do with these endpoints in our demo. So if we have a base URL, for instance, like this hipmonk.com, we can also get additional info with a parameter, a query parameter such as this. So this is a hash-based query parameter, but it's essentially just picking up on the from airport code and the to airport code. And then it's passing in a date. So this is a very similar approach to being able to limit what information we get back. And then with this, our JavaScript can then interpret the information and be able to process it. So we call this a hash, which if you think about it, all the different pieces, think of it like hash browns. It's kind of where that term, I think it's Germanic in its root of the term hash, but it's essentially many different pieces. So we're taking all of those different pieces and being able to create a function to help us then process that information. Okay, so here's our architecture so far. We got the model, we got the view, and now we're going into controllers now. So note that each resource can contain its own controller. So if we have just a articles section, that is a resource. If we have an about section, that's a resource. And we can have a controller that can help us utilize those resources and actually display the information or kind of trigger it. It's essentially the manager of our resources. So what Page.js is doing for us is it's essentially hooking into that history API that we just demoed to be able to capture clicks and push the current state of the browser to the address bar, thus preserving its history. And here's an example of actually what some of the page invocations look like. So the two base parameters are essentially the URL path or the endpoint, and then the actual method or function that you want to be invoked once that route, endpoint, or resource is hit in the URL. And the documentation for Page is actually on GitHub, so there's lots of good demos. The one that we're going to be doing is going to be in the lecture folder for the class repo today. Which has been updated if you would like to git pull upstream master. Which should contain a blank app.js file. So we're in the lecture-301B7 repository inside class 11. Go into lecture. Go into demo. And we should see 4 files. And if you don't have a blank app.js file, you can wipe it clean. We'll start fresh. Okay, so if you had to guess what the first method to set up page would be, we know it accepts 2 base parameters, but if we want to actually invoke page essentially as a base listener, we can invoke it just by calling page. Now in our index file, let's just kind of get a brief catch up on what we're actually doing here. The body is very basic. There's a heading h1 with a server. We have only one paragraph tag which says initial content, so we're assuming that the server is just initially sending us just this baseline content. And then we just have 2 links. We have a home link and a contact link. And then here we have the page library incorporated, and we also have our app.js file. So very basic. Now once we actually invoke page and get that set up, now we can actually register some route handlers. And we do that by invoking page again, except this time we want to pick up on a route. So what should our base route be? Home. What's that? So a home route for page is going to be just that /. That's going to signal that we are actually on the home page. Now we don't have a function built out yet, so we actually can't call anything in here. So we'll just end the line for now. But we want to set up another one based on contact. Now just for clarification, we said that the / was our home route, but look at our href. There's that /. So when we click on that link, page is actually going to intercept this because we've defined it right here. Now for this link, we have a /contact href. So we want to be able to set that up. And again, we don't have a function built out yet, so there's nothing we can call in this case. So let's change that and let's build out 2 functions. The first one will be index. And we don't have jQuery in this case. So who remembers our good old document methods? We want to target that paragraph tag. So we're selecting the paragraph tag and we're updating its text content. And we're going to say index page generated on the client. Because we only had one paragraph tag in that HTML. If we had two, it would update both. And remember that the initial content of that paragraph tag is literally initial content. So when we click on the home button, we want to update that content. So now that we have a function, we can reference it right there as the second parameter. Or our literal argument in this case. Our second function will be for the contact link, which we can call contact. We'll attach another document query selector for our paragraph tag. And we'll say contact page generated on the client 2. So how's this looking? What are we forgetting?
Cool.
Now we need to also update our page invocation for the contact href for whenever we click on this link. We want page to be able to intercept this href that we've placed in here. So we will have it invoke our contact function. So page is what we'll be invoking our functions in this case. I'm going to go ahead and save it. And within demo, run live server. Okay, so for my address bar, I'm at 127.0.0.1, and then my port number is 60655. We have our initial content. We click home. We have been updated. Now if we click on contact, we see that also updates, and so does our address bar. We have /contact now updated in the address bar. What should our history length be at this point? History length is 3. So the initial load of the page, the click for home, and the click for contact. So how much sense is this making with our thumb meters? Any questions? Now what happens if we change this in the address bar? So we'll go back home. So that's fine. Now what about if I put in /contact? And we're getting an error back. But we didn't get that error when I actually clicked on contact.
Yeah, okay. What is it weird with live server? Because it reloads it all like automatically on?
Right, when we actually hit refresh here, we're literally requesting to get this page. Our href was only relative with contact, but when we have this whole path in here, live server's trying to serve up that, and it's saying, I don't know what that is. Now, when we incorporate a node server into our assignment for today, it's going to be able to help us out with this. And so that way, even if we click, or if we actually enter that into the address bar, it'll serve up the content for us regardless. So it won't error out. My cool site. That's the title. Okay. So if we're ready, let's talk about our node server and our package.json file. So we're going to be utilizing our node server from here on out. And with that, we're going to be able to pick up on useful modules on the back end and moving away from live server. So we're actually going to be utilizing our own server, which is going to give us greater control, especially tomorrow when we actually request our GitHub projects, our GitHub portfolios, our repositories for our portfolio assignments. So let's go ahead and load our 11 SPA routing lab assignment. Anyone done any tutorials on Node?
Is anybody else having trouble staying on
Is it
Is dropping consistently?
try turning your Wi-Fi off. Try turning it back on. See if you can connect to that access point again. Yeah.
I've been doing that.
Oh, you have? Okay. Hasn't been updating anything. Okay.
I'm okay with mine. I was wondering if it should be.
It's probably a few. My laptop's notorious for.
Doing well today. No
You been
problems.
good?
Nothing
You
to
been
do
good?
with the internet.
It has been acting up?
No, mine been fine.
Oh, it has been fine. Okay.
Spa routing.
Yeah. The spa routing. I like that. That's good. Yep, you can fork and clone, and then feel free to create a lecture branch to follow along with. I'll actually be pushing up everything we do today in the master branch so there won't be any immediate merge conflicts. We won't have any automatic changes in our histories. So to give you a brief summary, Node is essentially just a runtime for JavaScript, just like the console essentially is. So with the console, we get the REPL, read, evaluate, print, loop, and in our terminal, we get the same functionality. So if I just type in Node right now, that'll actually step me into a REPL, just like we get in the console. So within this REPL, I can do simple math, 2 + 2. I can console log hello. Pretty much have most of my basic operations just like I would have in JavaScript. Now what'll happen? My question to you is, if we type this in the browser, what do we get? We get the window. What's going to happen if we type this into our Node REPL? We're in a different context.
The OS.
Should we do it?
Of course.
Whoa! What is this? We see lots of properties, objects, lots of different things here. This is different. This isn't the window, is it?
Tells you the version of the node you're running on.
Yeah. This is Node. With all of its properties.
I see the architecture property, and it's just a little bit up. Can you scroll up a little bit? Yeah, architecture x64. So is that the machine itself?
Yeah.
Yeah.
You don't think so?
Sure.
So on a high level, our this has changed. So we're in a different context, but I just wanted to showcase that. And if you need to exit out, you will essentially Control C twice to exit out of that. Now, if you want to read up more about Node, their docs are really good. So I'll post a link to that. But just note that this going into Node in depth is definitely 401. So you're not expected to actually you're not expected to be like comfortable and write a Node server. You can utilize the one that we write today, ongoing throughout the week. And if you want to incorporate that into your portfolio assignment, you can do that as well. You're not actually expected to be able to like write a Node application from scratch in this class. Okay, so what we've been using has been live server up until this point. But to actually use Page.js to the fullest extent, we're going to need to actually build out our own router or build out our own server. Okay, so within here, if we go into starter code, we see our admin page, our data, index, new, script styles, vendors, everything's pretty much good. Now let me showcase what our end goal will be for today. And this is a spoiler of sorts because the stretch goal has also been completed. All right, so Notice the address is updating, and we're just hiding and showing like normal, but we're using Page instead of jQuery now to be able to handle these routes for us and update our history. So this is what we'll be working towards today. Okay. So we should start let's start by making a server. So we're gonna touch server.js within starter code. Within our starter code folder. Also notice we have a controllers folder now, so we have complete MVC file structure ready to go. And here's our server.js file. Okay. Who's heard of Express? So in the mean stack application, we have Mongo for our database, Express for our server, Angular for our front end, essentially replacing jQuery, handlebars, and Page. It's kind of like an all-in-one solution. So Angular is the front end application that the current 401 students are actually working on right now. And then the N in mean is for Node. So we're going to have Node and Express literally right here in this server.js file that we're going to build out. So the first thing that we can create is our instance of Express. And Node uses this require pattern to be able to pick up on different modules. And you'll find in the export pattern, our module.export pattern, we can actually specify what we want to expose to other contexts. So if we were to say, let's assume that, for instance, we're creating some articles module. And if we remember our IFI or our closure pattern, where we say module.article equals article, we can actually, in Node, we can specify that we want to export that, which will give us the ability to require it in other files. Express has already done that for us, so we can simply call require on it, but we still need a copy of it locally. So we can't just say require and expect to get it from the cloud, so to speak. We actually have to have that available. So we're going to include a copy of Express once we complete this server file. But for now, we're going to assume that we do already have it. Now this comma is a shorthand for being able to explicitly state multiple variables. If you have multiple variables in the beginning of your application that you want to assign, you can do so with the comma. What's line 2 doing, if you had to guess?
Setting a server port.
Setting a port to be able to listen on. So with live server, we would get some default port number, which it would attempt to default to a particular one. If you had 2 instances of live server, you would typically you would notice the information that it said port is already in use, so trying another port, it would add like 5-digit port number to be able to pick up on. So here we're doing the same, where we can specify a default, but process is an object in Node that we can actually, we have other variables attached to. So process.env is something we're actually going to be utilizing for our GitHub files. We're going to actually be able to create this application token. So when you sign up to get repository information back from GitHub, you actually need a token file that is a secret, it's basically a secret key. And we'll be able to abstract that away into the process to be able to keep our information secure on our end. And then also when we deploy to Heroku, we'll be able to keep that information separated. So it'll keep it secure on both ends of the communication channel. So just note that that process is just an object that we can use within the node context. And on that, we've assigned this port. Line 3, we're essentially instantiating an Express instance, and we're saving it into app. So this is pretty common practice. So now with this instance of an Express app, we can actually we have methods available to us, just like we would with any other object. So we can say app. We can call app.use. And what line 5 is doing for us is essentially serving up it's serving up our initial content. So if the / is our home page, we're going to serve up the contents. But in this case, it's going to be from the starter code folder. So we want to have access to all of the files within our starter code folder. So that's what this app.use is doing for us. Backspace. Another method that we have available to us is get. Without writing anything else, what do you think that this method has to do with our project or our application? Kind of like $.get. Okay, we can think of it as a web request response cycle that's being initialized. So we therefore have access to a request object. And with any request, we also get a response. And this, again, is all within the functionality of Express. So this is something that Express is actually expecting. It's nothing that we're just creating on the fly. This is actually a method get for Express to be able to use and target any URL. In this case, we want to pick up on any path. So that's why we're specifying this wildcard star flag. So think of this as any URL. We want to be able to have access to the request object and the response object. So within this get request, all we want to be able to do is provide useful information to the developer to see what request was actually being made. And this is going to be similar to what LiveServer was able to provide for us as well. And since we have access to this request object, we can pick up on its URL property to see what URL was entered or requested. And now with our response object, we have a method available to us called sendFile. Again, this is all within Express and its functionality. So we want to initially state that we want to serve up that index file. And then we can explicitly state where we're expecting that index file to be located. So our root is going to be the starter code folder. Now with this code so far, we we actually haven't started anything. The server is not live at the moment if we were to run this file. And in fact, we should try that. So let's save this. And we have our server.js file. We can call node server.js. And nothing happens.
Except there's an error for everyone else because they don't have Express.
Ah. Yep. I've saved mine globally, which we can do in a moment. So you're going to get that error regardless, but to actually set up the server, we need to call the listen method on this. And this console log is not necessary, but it again is providing useful information to the developer to see that we have actually started up our server. There are other shorthand methods to use instead of concatenating, but this is a little bit easier to read. So we're just going to log whatever port that the server actually started up on within this anonymous callback function once we've set up that connection. So we can save this. And again, it may not work since we don't have Express, but in this case, we do see this console log now as a result of starting up our server application. Okay, so with this, it brings up the interesting point of node dependencies. We require it in Express as a dependency, just like we would for Page.js as a library. And with Node, we have the ability to bring in other packages or modules with NPM, our Node Package Manager. So with NPM, we can actually specify which packages we want to incorporate. Now, the typical approach for this is to say npm install, and then you would specify whatever package you wanted to. In this case, Express. Now, for the result of our application, we could run a -g flag for global installation, which would then give us the ability to have access to it anywhere, which is good for the most part. For an application like Express that's utilized widely, this would be okay. So if we hit enter, we see npm doing its thing.
You get a lot of errors.
You mind taking a look, or is that
have to do
sudo? Yeah, you might have to run a sudo command if you're not getting permissions. So you could arrow up and you could attach sudo to that. Another shortcut is to do this. What will this do? This will run the previous line that you entered, and it will prepend sudo to that. So if you need permissions for a command that you just entered in, and you don't have permissions, you can just run sudo bang bang, and it'll run it in that context.
And there's a space between sudo and the double bang?
With the double bang, does that just run the line above with?
With sudo prepended.
Okay, so
Yeah.
can you do that with anything?
Yeah, you can do it with anything. So
Doesn't-
yeah.
Rick, so when we install Express without that global flag, what is the scope of that installation?
Yeah. So what we really want to do is make it explicitly available to our application. So that brings up the topic of package.json. And it's a requirement for any application that you develop in Node with if you have different dependencies. It's also utilized in testing. You can specify what tests you want to run. And you can also pick up on different pieces of code to run when you have different commands that you start with. And what package.json is also useful for is being able to run other applications from anywhere. So we can actually, if we were to say you wrote a program on GitHub and it has a server file with a lot of dependencies. Those dependencies we can get with NPM. So one thing that you should not do are push up those dependencies to GitHub because they're already living on a server for us, on the NPM server. So one way to prevent that is to actually add these dependencies to your git ignore. If we go out one directory here, and if we do an ls-a, so we're in the 11 SPA routing. I love saying that now. I'm just going to keep saying SPA. And that we see a git ignore file when we do ls-a. Now if we cat the .git ignore, this is actually a generated git ignore. I believe there's a site called gitignore.io. There's one where you can actually generate a git ignore based on the operating system you're developing for. So here's our dependency directories field. Anything with a hash is going to be a comment in a git ignore file. So these are just helpful comments for us to see. So anything in here we're actually ignoring. Nothing will be pushed up to GitHub that's in this .git ignore file. So we don't want to push up our node modules folder. We do not have node modules yet, but when we create our package.json and we explicitly state what dependencies we want, it will add it to that, and it'll create a node modules folder for us for our application to use locally. Now this package.json file should live within the same level as our server.js file. So we're back in our starter code folder. If you had to guess what type of, what data type package.json is, what would that be? Just JSON, right? So we could create that. We could create that quite literally. We could touch package.json. We could go into Atom. We could fill in all of the requirements for that. Or we can use npm to help us out and run npm init. And what npm init will do is generate a walkthrough for us in building out this package.json so we do not have to. So we start npm init, says this utility will walk you through creating a package.json file. It only covers the most common items and tries to guess sensible defaults. And then you can run npm help JSON for definitive documentation. There's also good documentation online as well. And it says we can press Control-C at any time to quit. Now the first option we have to enter is the name. So this is going to default based on the folder that we're in. So I'm going to change this from starter code to something that's actually a little bit more meaningful. So I'm going to call this blog-app. You have to be careful with naming because there's certain things you can't do. I'm pretty sure you can't have a number that begins with it, and then pretty sure you also can't have spaces. There's some other conventions that you have
Only
to.
lowercase too.
And only lowercase. So it's very particular on the name here. So we hit enter. It takes us to the next field that we want to build out. So notice these are all properties. So name is a property, version's a property. In the case of our application, we can assume that we're already on the initial first release. So we can keep this as is. So anything in these parentheses are the defaults. So we don't have to enter anything in this case. We can hit enter, and it takes us now to description. And we'll say MVC for the win, exclamation point. Our entry point defaults to server.js. Since we've already created that, this is what we want. This is good. So we can just hit enter or return to carry on. Now, if we had a test library that we were going to actually use, we could state the command to run that test, to specify the path where our testing should take place. That's 401 related, so we can bypass that and just hit enter. The Git repository would normally pick up the actual path to the repo, but we're not actually required to enter it into here, so we can hit enter here. Keywords are also not required. Author, the typical convention is to enter in your email address. And you can hit enter. The default license is ISC, which stands for Internet Systems Consortium. Between this one and MIT, those are the two most common licenses for applications. I tend to favor MIT over ISC just because of its explicit nature. But you can go to this site and get a series of all of the available licenses, and I just slacked it out, that you can use. In this case, I've generated the ISC one. Let me back up. So look at all these. These are all licenses that you can state for your application. So most open source applications use MIT. I'm going to delete this old one because it was pointing to the ISC one. So there you have a list, and if we actually go down to, here's the MIT license. So we'll take a look at this one. So there we get the full name. And then here's the actual text of the license. So permission is hereby granted free of charge to any person obtaining a copy of the software and associated documentation files to deal in the software without restriction, including without limitation, the rights to use, copy, modify, merge, publish, distribute, sublicense, and or sell copies of the software, and to permit persons to whom the software is furnished to do so, subject to the following conditions. The above copyright notice and its permission notice shall be included in all copies of substantial portions of the software. So this is saying, look, this is open source. Feel free to use it. We just want credit. Just showcase your credit in your application. And then there's some good documentation here that says the software is provided as is without warranty. So this is just other legal representation to basically state, hey, we're not making any guarantees about the software, but here it is.
I also just slapped out a link to a website called choosalicense.com that gives plain text kind of descriptions of what the different licenses mean, so you don't have to read all of that.
Yeah, it's also really good if you come across other applications and you see a license that you're not too fond of, and you want to be able to look into what is actually what's actually allowed for that particular application. So really, really helpful information here. Okay, so we have ISC. I'm just going to type MIT to overwrite the default. So again, these are all just different properties. Now, once I've finished off the license, it pops up with this message saying about to write to, and it lists out the path. And so here's our package.json that it's about to write. But now notice what it did for us. This right here is just our preview of what the package.json file will look like, which is just a JSON. We have our properties and our values. Name blog app version 1.0.0, description MVC for the win, main is server.js. Any scripts, we have a start command, which if we just type npm start, then it's going to run node server.js. So we could run node.server.js in our terminal, or npm gives us the ability to execute a start command, which will do the same thing for us, node server.js. And then there's our author and license properties. And at the bottom, it asks if this is okay. The default is yes, therefore we can just hit return. And we're back out into starter code. Now if we type ls, we see that there is indeed a package.json within our starter code folder. And if we cat the package.json, there are the contents. And it'd be the same thing as if we go into Atom right now. So if we go into Atom and look at our package.json, we see the same thing. There's one thing left that we still need to do. Because if we were to run npm start, or if we were to run node server.js, we may or may not have Express depending on how you installed it. But for other people who don't have Express, we want them to be able to utilize our application without having to explicitly say npm i -g express. We want to be able to have our application make that available for them. So we need to actually update our package.json. There's one thing left to do here. And that's going to be npm install -- save express. So the -- save flag will update our package.json by adding a new field called dependencies, which are any modules that your application requires at runtime. So in the case of our application, we want Express. We want to add it to our dependencies. So we can run npm install -- save express. So we get the same information back as we did when we ran the global installation. But what changed? Immediately, what do we see different in our structure now? We have a node modules folder. Let's actually look inside node modules. Let's take a look. Now what happened here? All we did was install Express, but we have all these other folders as well. In the early days of NPM, if you would install a package such as Express, you would typically just see that module, Express. But then within Express, you would see its dependencies, and then those dependencies. So you start getting a lot of nested modules. This was a big issue in operating systems such as Windows, because they have what's called a max path range for their file structure. So if you have a listed path of all of these, if you have nested modules that point in an actual path string, the limit for that is 255 or 256 for the character limit. So anything beyond that, it couldn't pick up on it, and it would actually error out. So what they did, beginning with NPM version 3, is they flattened this structure out. So now any dependencies are all within the same level. So they're all within this level now. So any of Express's dependencies are right alongside any dependencies that those dependencies might have.
Would that also make it so that you don't have redundancies? Because if you have another package that also requires send, then you don't have to have two copies of it?
Yep. Yeah. So there's a couple benefits with that.
Is the npm warn log app no repository field normal?
No repository field. Yeah, that's fine. And you can always update that to point it to the repository for today. So you can just copy the link for the lab assignments repo, and then you can you can place that in here, but it's not required. All right, so let's go back out to starter code. And let's cat our package.json now. And we see that our package.json has also updated because we now have this dependencies field or property with Express. And then all this is doing is listing out the versions. So this is what is actually going to be downloaded for us. If a new user were to clone this application down, all they would have to do is run npm I, and that's going to search through this package.json file and head to the dependencies field and download anything right here. So if we were to go to github.com and find some repo that has a node server on it, and that server has dependencies that we currently don't have, if we were to clone that down, go into their folder, run npm I, we're going to be able to get all those dependencies without having to explicitly run npm install this dependency, npm install that dependency. It'll just go right to this dependencies field and get all those for us.
HUB,
Yes.
can you flip the switch on the power strip by your foot? Thank you.
Okay, so with this now, we can do two things. We can run npm start, or we could do node server.js. And we're getting the same result. Anyone not getting that result? We're over on our break, so let's take a break, and if you're not getting that, we can take care of that during break. And when we continue back, we'll actually walk through some of the to-dos.
Rick, can I see your servers .js file?
Server.js.
Outside.
So for at line 9, the send file, is that a capitalized S at the beginning or is it lowercase?
I think it's actually lowercase. Yeah, thank you.
Oh.
Good catch.
Yeah, and then you had to.
Yeah, I was going to that port
Yeah.
2000, and when I click on a link and it says send file, it's not a valid function. So
Yeah.
there.
Thank you.